Alright guys, what's going on? We're doing day 4 today of Advent of Code 2024. And it's going to be in Kotlin again. Hopefully we don't have to use such high level constructs like we did last time on day 3, you know, like regex and stuff. I'm going to try and keep it more principled in terms of the algorithm we use. So hopefully it works out. Let's see how hard this actually is. Alright. Day 4. Looks like the chief's not here. Next, one of the historians pulls out a device and pushes the only button on it. After a brief flash, you recognize the interior of the series monitoring station. As the search for the chief continues, a small elf who lives on the station tugs on your shirt. She'd like you to know if you could help her with her word search, your puzzle input. She only has to find one word, Xmas. This word search allows words to be horizontal, vertical, diagonal, written backwards, or even overlapping other words. It's a little unusual, though, as you don't merely need to find one instance of Xmas, you need to find all of them. There are a few ways Xmas might appear, where irrelevant characters have been replaced with a dot. Okay. Yeah, so this is diagonal. This is backwards. This is also backwards. Horizontal, forwards. Okay. Yeah. Let's search again, but for letters not involved and any Xmas have been replaced with. Okay. Yeah, this is going to be really hard. Wait, what about this M? Where does this M go? Oh, yeah. I don't know about this S. Oh, okay, that one. This A. Yeah. Yeah. Wow. Okay. This might take me a while. But we're going to be principled about it and try and just use, you know, C classical constructs, not just functions. Okay. This is our input, and we have to uncover horizontal, diagonal, vertical instances of Xmas. So I think the best way to just start is to basically, we're going to have to create oh man. It can be backwards or forwards though, that's the crazy part. Which might not actually be a big deal. Maybe we can just look through every X, right? Because if there's an X, then there's potentially an Xmas. And then we can just look horizontally, diagonally, vertically, whatever, to see if the other characters follow. That might work. We would need a two-dimensional array for this, I think. So, let's think. And I'm going to be referencing characters a lot, so I think the first thing I'm going to do is create an array of the characters that we're looking for. Let's do in, for instance, and then array of. So these are our characters that we're looking for. And I would like to create a two-dimensional array of each character from the input, because then checking for horizontal, diagonal, etc. is simply a matter of offsetting the row and column in a particular manner whenever we find an X. Which this could take forever. But I think that's what we need to do. Because if we look here, every single X is an instance of Xmas. Right? Every single X is an instance of Xmas. And I don't know. Okay, yeah, right here. We can use the same X for the same Xmas. So it doesn't matter. So we really are just going through each X, doing, seeing if there is an Xmas in these directions, and then counting it. So it's not actually that hard. I just need to get the two-dimensional array going. So we have input in lines. Is it a square? Like, could we just count it? It's probably not a good idea. Okay, I know what to do. So we already have our matrix essentially. It's just input. That's a series of rows. Is your list string here? Okay. I guess we could just do so we're going to split this mat, and I'm going to print it out just to see what it looks like. Okay, we're back, and I think we have something going here. Basically, we took the input, the list of strings, we mapped it to a we mapped each string to a char array, and now we're going through the mat, each row, and each column. And we're checking if the element, the character, is an X. And then here's where we do our checks. So the first thing we want to check is if I, which is the row, is less than, or sorry, greater than 2. Because Xmas is 4 characters long. XMAS, right? So we need to make sure that we're farther, because otherwise we're not going to check if it's vertically up if we're on the first 3 rows. So we actually want to make sure we're greater than 3 here. 0, 1, 2. Actually, no, this is right. Because if it's greater than 2, it's on I is 3, and that's row 4. And then we can check vertically. What I first want to do, though, is check like regular, left to right. And do they want the amount of times, right? Yeah. So that we're gonna check. We're gonna make a count variable. And we're gonna return that. So let's go ahead and check left to right, and this means we have to make sure that we have 4 characters ahead of us. So that means that J is less than mat I size minus 3. Right? Yeah. Okay, and if this is true, we just look ahead and say if mat I j plus 1 is x and mat I j plus 3. And sorry, this should be 0. It should be x miss then count can plus plus. So that's the horizontal case accounted for. Okay. So let's see how many horizontal cases there are. $192. Okay, and now we're going to do the opposite. We're going to go backwards because it could be both ways, right? So that means J is greater than 3. Actually, it should be greater than 2. And I already have that here. No, that's I. Okay. 0, 1, 2, 3. So this means if J is 3 or greater, we can go ahead and do what we did here. But we need to change this to be minus 1. Minus 2. Oh shoot, sorry. Minus 3. Okay, now we have backwards cases. So how many does that add? Adds a lot more. So we know we're doing this correctly because it's incrementally getting larger and larger, as it should, as we add more and more cases. So let's try the vertical case now. So these are the horizontal, backwards and forwards. Now we got to check up and down. And then finally we got to check the diagonal, which is not as hard as you might think. So yeah, let's do this. We're going to check above, because we're making sure I is greater than 2. Okay. So really the code doesn't change much. -1. It's only these indices that are changing where we're actually looking. The length is the same, so the actual checks are always 3. It's just the offset is different each time. And let's go ahead and do the downward. I has to be less than mat.size -3. Okay. Let's see how much we have now. We've done everything but the diagonal cases. So it's 800. So we have 4 diagonal cases that we have to account for as well. These are all the straight cases. So we have right to left. Sorry, left to right. This is right to left. This is upward, downward, so north, south, west, east. And then we got to do northwest, northeast, southwest, southeast. So let me actually just write that down. It should be north, whoops. So with northeast, we want to make sure we're greater, and okay. So we do that, and okay. Should be greater than 2, not 3. Okay. So with diagonals, you're going to change both the x and the y, or the row and the column. So we're going to decrease the row and increase the column. So let's make sure. Let's see if that works. Yep, it's working as expected. So here we're going to make sure that j is greater than 2. And with j we're going to decrease. So south, we gotta make sure our I is less than mat.size minus 3. Yep. Same thing here. So for southeast, we gotta make sure I is less than mat size minus 3. Yeah. Okay, I think everything's good. Just gotta change these accordingly. So j is less than, so that means we're going to increase j. Same thing with I. Southeast, yeah. Damn it. So if it's less than, you're going to increase it. If it's greater than, you're going to decrease it. So that in this case, I is getting increased. J is getting decreased. Which is true, right? Yeah. J, yeah. So we should be good. I think this should give us our answer. Let's try it out. Oh man, I really hate that you're I can't copy paste. I don't know why, but nice. Okay, that's awesome. So yeah, I mean it's pretty straightforward. You're just checking, you know, it's about what you'd expect the algorithm to be. It's pretty much linear. I mean, I don't know if it would be considered linear actually, because you're checking a lot of the same elements over and over again. So maybe it's quadratic time. Let's move on to part 2. Okay. The elf looks quizzically at you. Did you misunderstand the assignment? Looking for the instructions, you flip over the word search to find that this isn't actually an Xmas puzzle. It's an X-Mas puzzle, in which you're supposed to find 2 miss in the shape of an X. One way to achieve this is like this. One way to achieve that is like this. Wow, okay. Irrelevant characters have again been replaced with a period. Within the X, each mass can be written forwards or backwards. In this example, we have mass appears 9 times. Flip the word search from the instructions back over to the word search side and try again. Okay, so this is a bit harder. Oh, but look what we have that's always in common, right? This is actually easier. Wow. This is actually much easier because the A is always in common. And guess what? We're only looking at diagonals. So all we have to do is check for an A, and then we're going to change these conditions a bit because it could be forward or backward. But yeah, that's much nicer actually. So we're going to do, it's going to be 4 cases. And so we can get rid of these straights because we don't actually need those. Four cases. When we find an A, we check for an Xmas. And we're going to decrease this. Ooh, and this is actually different because we have to check each side because A is in the middle. So I think we just got to get rid of these conditions and start over. So when we find an A, for this case, we're going to check if I is less than the mat.size minus 1 and right? We're checking for this character, so and let's see. And J is greater than 0, meaning it has to be 1. If it's 1, it still works. Yeah. We actually have to do a bunch of checks here. We have to make sure that we are in a box that works. And then we can just check and see so we're trying to make sure we have all the dimensions of the box. This 3x3 for the Xmas. We're not actually checking letters yet, so we just checked the left bottom corner. So J is less than and J. Oh, we could do and. Okay, this should be our condition for our little rectangular box. And then we can just check. We can just start offsetting I and J, and we should be good. Alright guys, we're back. And I just want to go over what we've done for part 2. And I'm actually about to check if it's correct. Basically, we just check if both are forward. What I mean by that is both forward means from left to right, both of them start with M and end with S. And then for backwards, I just switch the letters. That's the nice thing about these conditions, is that you only have to switch the letters here. There's 4 different possibilities, and you're just changing. It's just a different permutation of 4 slots, 2 types of elements. So yeah. And then that's error. But let's see if let's run this and then see if we get it right. And of course, I think this thing like breaks whenever I'm using OBS, which is kind of annoying. So I'm going to pause it and then I'm going to get the answer real quick. Okay. Hopefully we figured it out. I'm a bit surprised that there's more Xmas's than there is, you know, the first occurrence here. But let's see. Nice. Alright, so that's day 4 complete. Thank you guys so much for watching, and hopefully day 5 is pretty interesting, so we'll see in 10 hours. So yeah.